I just want to introduce myself. My name is Gene Whitaker. I'm here to talk to you about TextKit. And I work for a company, well, I own a company called Bombing Brain Interactive. And you can find me on Twitter, Gene_Whitaker. I'm not the most active person in the world, but I do check it pretty often. You can also find us at Bombing Brain, or you can email me at gene@bombingbrain.com. So, we make two applications. First one is our flagship app. It's called Teleprompt Plus. It's a teleprompter for the iPad. It's professional. It can control multiple devices, other iPads. It can synchronize with iPhones. It can synchronize with Macs. And we also have an app for musicians called Setlists. So this is a lyric prompter and setlist manager for musicians. And as you can probably tell by looking at our apps, we do a lot of work with text. And so I wanted to do this talk because TextKit came out 2 years ago with iOS 7, and yet there's very little coverage of it out there. There's a few articles. There's an article on Ray Winderlich. There's a few good articles out there, but it's not really that well talked about. So I wanted to kind of put it out there and kind of show people what we've done with it. So to get started, I wanted to do a super brief history of text on iOS. I'm not going to spend a lot of time on this because you can get this from the WWDC videos. So before iOS, we had the iOS text components: UI label, UI text field, UI text view. These are pretty static. You couldn't really do any rich text formatting with them other than setting it globally on the entire object. So, for example, label.font equals font with name, etc. Then iOS 6 came along and something changed, and it was very much for the better, but still not quite there, and that was that they added support for an NSAttributedString. So let's look at the stack, the text layout stack for iOS 6. Hit core graphics, string drawing, core text, and WebKit. And on top of that were our text controls, and also UI WebView. Does anybody see anything weird about this picture? Okay, what I think is weird is that we've got WebKit underneath UI text view. And that is exactly the case. And this was actually one of the quiz questions from the Stump panel yesterday that I put in, is how did UI text view lay out its text in iOS 6? And the answer is it laid it out using HTML. So we're getting there. The problem is that it could only display it. You still couldn't edit it. There really wasn't any rich text formatting that you could edit yourself. If you wanted to do that, you had to roll your own using core text. And let me tell you, that just sucked. So one of the things that everybody who knows me knows that my position on this is that I've been working in the Apple ecosystem for 5 years now, actually more like 7. And what I find is if you want to do something amazing, like have 3D rendered stuff flying across the screen, that's like one line of code. But if you want to make text a one word, bold, that's impossible. Things that are incredibly hard are extremely simple, yet things that should be extremely simple are incredibly hard. Well, in iOS 7, Apple changed that. And they introduced TextKit. So what does TextKit give us? It gives us rich text editing, formatting and syntax highlighting, custom layout, user interaction, annotation, text effects, text highlighting, custom text input behavior, and interaction with UI elements. So what is TextKit exactly? It's three interdependent classes: NSTextStorage, NSTextContainer, and in between them lies the glue, which is NSLayoutManager. You can think of these sort of as model, view, and controller, except this is not exactly right. NSTextContainer models the geometry that text is going to be laid out in, but it's not the actual view. The view is the view that it's going to be drawn into. So really, TextContainer is still part of the model. But still, these three interdependent classes, they work together to lay out, to manage the storage, the geometry, and the layout of glyphs. What the heck is a glyph? A glyph is a graphical representation of a character when you apply treatment such as font and size, style, bold, italics. In iOS 7, they also added the support for ligatures. A ligature is where you have text connecting like this, like you see how these two F's come together. Now, the important thing to note is that there isn't a one-to-one mapping between a character and a glyph. So at the top, the A, that's a one-to-one mapping. But the bottom, that's two characters on the left. But on the right, that's only one glyph. So that can really trip you up. But luckily, the Layout Manager gives you methods to map the two together. The first is glyph range for character range. And then there's the opposing method, character range for glyph range. So this will allow you, when you're working with text that's laid out on screen, to actually identify the characters at different positions in the text. So let's look at the modern architecture for text. Still have core graphics on the bottom, still have core text in there. But now TextKit sits on top. WebKit just isn't there at all. It's off to the side. It's supported by some of these elements, but it does not support any of the core text objects. There's one additional thing we can put in here, too, that we didn't have before, and that is you can now roll your own text views. I don't mean like UI text view. I just mean you can roll your own layout. So I'm going to talk a little about the relationships between these classes. Normally, you would have one text storage. So the text storage is what stores your text. That, in turn, connects with the Layout Manager, and the Layout Manager renders text to one or more text containers. Now, you can also have a text storage attached to multiple layout managers. And that layout manager, in turn, can have a different set of text containers. Why on earth would you do this? Well, the top diagram, let's say, theoretically, could be your app's layout. You might have a multi-column view or something like that. The bottom layout manager might be specifically designed for laying out text when you're going to print, which may be different than how it's going to look inside your app. So that's why they have this structure. So now I'm going to dig deep a little bit deeper into these classes and talk about them. So NSTextContainer. This identifies the geometry in which the glyphs will be laid out. Okay? It's not a view, but it's identifying areas within views where the text can be laid out. Also, text containers don't necessarily have to be associated with one view. Or actually, I'm going to flip that around. You can have one layout manager laying out text to multiple text containers in separate views. It allows what's called exclusion paths. I'm going to show you that in a minute. And then you can subclass this class to do even more customization. So here I have a text container. And what I want to do is I want to add an exclusion path. So this is just a UI Bezier path. And when the text is laid into that text container, it will lay out its glyphs around that exclusion path. So that's exclusion paths. NSTextStorage. So this is your database. This stores the raw strings, including the formatting. Okay? It's a subclass of NSAttributedString. Does everybody have some familiar with NSAttributedString? Okay, so I'm going to talk a little bit about that later as well. The other thing that text storage does, which is really important, is that it notifies the text layout system of content changes. So anytime you make a change to the text storage, it's going to push those changes out and tell the layout managers that it's connected to relay out the text. Subclassing of this allows customization of how you store the text and also how you might display it. And I'm going to show you that at the end of the talk. Finally, there's NSLayoutManager. Now, this is kind of the glue that holds it all together. What Layout Manager does is it coordinates the glyph layout for the given text storage and also the containers. It maps the characters into glyphs, and it sets those glyphs into a series of text containers. You can also subclass NSLayoutManager to do customization of glyphs. So here's kind of how the layout process works. You've got your text storage. Text storage stores the attributed string. You've got a view that you want to put your text in. You define text containers that will contain the text. And now you need an NSLayoutManager. What the Layout Manager is going to do is map those glyphs from the characters, and then based on the text container's geometry, it's going to lay out its text into bounding rectangles. And then it's going to lay those into the text containers. So how can you customize this layout of your text and behavior? Well, there's direct manipulation of the classes themselves, subclassing, and delegates. So why would you do this? Well, you would subclass NSTextStorage to override how text or attributes are stored or displayed. So, for example, Xcode is a perfect example of this. The text itself is just text. It's not formatted, but when you view it in Xcode, all the terms are highlighted and text colored. So it's a perfect example of a custom text storage. Subclassing NSTextContainer can allow you to store implementation-specific information, like, for example, indexes, tags, or coordinates. So if you're doing a multi-column text view, you might want to store which column this text container is. You could also store its coordinates in the relative geometry. You can also implement complex drawing paths, what I call inclusion paths, and that's not really an official term, so don't take that as one, but to do a layout like this, where the text is inside of a path, you actually have to subclass NSTextContainer and return the specific bounding recs that the text is allowed to be inside. So it's sort of the opposite of exclusion paths. You can also subclass NSLayoutManager. What this does is glyph substitution, and you can also do custom line truncation. I really recommend the Advanced Text Layout WWDC 2013 video if you want to check out that. And finally, there's delegates. And the most important of these is NSLayoutManagerDelegate. What you can do with NSLayoutManagerDelegate? Well, first of all, you can customize your glyph mapping. So, for example, you've all seen password fields where you type in the password for a split second, you see the character, and then it gets replaced with a bullet. Well, TextKit can do that. The delegate also allows you to customize the layout behavior before the layout actually happens. So, for example, line or paragraph spacing, breaking, or truncation. So I'm sure everybody here uses Xcode, I'm assuming. You've seen this before where Xcode actually pops in an extra bit of line spacing underneath your code and throws you a little warning. That's NSLayoutManagerDelegate. It's customizing the line spacing after that line. Finally, the Layout Manager Delegate notifies delegate objects when the layout operations are complete. So this allows the delegate to position other UI elements based on text geometry. Now, this has never been able to be, this was not possible before iOS 7. And this is something that we use a lot. So our app setlists has a feature where we embed chords in the text. These are guitar chords for musicians. So what happens is the layout manager will notify us when the text is drawn. And then we'll actually, based on the positioning of that text, lay out guitar chords above that text. And the great thing is that if you edit the text beyond that, the chords will follow the text around. It's not like a rendered PDF or something like that. It'll actually travel around in the text view with that. So it's pretty powerful. You really can do a lot more with TextKit than you could do before in iOS. And by the way, this also exists on Mac, so it does apply there too. Now, working with TextKit is a little bit of a different story. It's a little bit of a challenge. In fact, I would say you have to be awfully careful, and even prepping for this demo, I'd have to say that sometimes it's just it's a pain in the ass. I promise you I will not use any more Giphies in this presentation. So the best thing to do is kind of show you some of the things that we've done with TextKit, and so I'm going to break into a demo now. So I've created a demo with a hypothetical business use case. So it's a newsstand music app, okay? Requires multi-column, flexible table text layout. I want to embed images and audio. I want the users to be able to interact with those components. And I also want a little bit of an editor app so that the magazine editors can actually create this content easily. I want it to be single column, and I want the writer to be able to actually embed that content into the audio. So the first thing I'm going to talk about is flexible layout. And specifically what I'm talking about is doing a multi-column layout. I'm going to do that using multiple text containers. Okay, can everybody see this? Yes? Okay. So, just going to show you what I'm going for. I think it's better for me to just show you what I'm doing and then kind of walk through how I did it, because otherwise you're going to just not have the context. So I have this magazine view, and I want to thank my friends Joe and Dave. I used their band as a guinea pig for this demonstration. So first of all, I just wanted to say that UI label, that's a UI label at the top. And that's a rich text formatted label. There's nothing special about it. I just did that within the storyboard itself. But you can do rich text now in labels. The interesting thing about this, though, is that I want my magazine app, since landscape's kind of wide, I want to have 3 columns there, but when I am in portrait, I really want to kind of limit that to 2 columns. So that scaled up. More reasonable. Okay. So as you can see, this is relaying out based on our orientation. So how did I do that? Well, first of all, I just have a page view controller, so it's just a view controller. And it's embedding a custom view that I created called column text view. Okay? Now, rolling your own TextKit stack really isn't that hard. I've created some properties for a text storage, for my own text storage, my own layout manager. And when I await from nib, I'm going to load the text. And then here's the good part, okay? I'll use this. So first, I'm going to instantiate my own text storage. In this case, I'm instantiating it with the text that I'm loading from a file. And then I'm going to instantiate a layout manager. And I'm going to tell you about these two things a little bit later. And then all you need to do is add that layout manager to the text storage. Okay? And then this item at the bottom is actually kind of important, because what this does is it tells the view to redraw when geometry changes. If I can actually comment that out and show you what happens if you don't do that. Not good. It's kind of doing the funky scaling and just not what we want. So we want to tell it to relay out the text when the geometry changes. So how are we actually getting these text containers on the screen, though? Well, that's done in our draw rect. Okay? So first thing we're doing is kind of just cleaning up stuff from before. Didn't realize it would control X code, too. So these calls are just doing some cleanup. Not really important initially because it's not doing anything. And then here's an important step. So here's a decision point where I'm saying, okay, well, how many columns do I want? So based on my size ratio, I'm either setting that to 2 or 3 columns. Now what I'm doing is just looping through, and I'm creating the text containers. Okay, so I create a text container. Now this is a custom subclass that I created of text container. And really, this doesn't do too much. It just stores the frame. It stores an index for the column, and then it has one special method that I wrote. Now, I wouldn't normally recommend storing your own geometry because it's just bad. You should leave that to the parent. But in this particular case, since I'm destroying and recreating every time, it's okay for this demo. So I calculate my frames based on the number of columns. I set up my column text container, and then I add them to my layout manager. So depending on whether I'm in landscape or portrait, I'll get 2 or 3 text containers. Then finally, I call layout text. What I do here, and this is what's really important, is now I'm telling my layout manager to get to business. Looping through my text containers, I'm asking the layout manager to calculate the glyph range that's going to apply to each text container, and then finally, I'm going to draw the glyphs into those text containers. Okay, so that's all you have to do to roll your own TextKit stack, and it's even simpler if you're not doing columns. So now let's look at the next use case. Now I want to do exclusion paths. I want to put some images into this. So here's how I do that. First of all, in the storyboard, I simply have an image view. I call it exclusion view. I have a little Boolean to just make this quick. So I'm going to turn that on. All that's going to do is unhide that image and then basically pass an exclusion path into my custom view. So what's important here is you have to get the rectangle of the exclusion path, and then I want to pass it into my column text view. Now I need to deal with it. So I'm going to go back to my draw rect. I've marked a little spot here where I'm going to put my text in, put my code in. Now this is important. The exclusion paths are laid out in the geometry of the text container, not the view. So you can't just take the exclusion path and apply it to your text containers. What you would get is, you would get the exclusion path in each of those columns, and it would look really strange. So what I actually have to do is compute the intersecting recs for each of my text containers with this path, and then pass those in as my exclusion paths. So it's a little bit complicated. And I have to admit I'm copying out a little bit because this is all just rectangle math. If you had a complex Bezier path, it's actually a lot more complicated. You could pre-store your Bezier paths externally. I'm keeping it simple in this example because, again, it's hard. All right, I think that's it. So I'll run. Go back into my magazine view, and now my column text is laying out around my image view here. If I rotate, it'll recalculate. So that's pretty good, but this is still kind of boring. What I really want to do is I want to add some interactivity to do that. But in order to do that, I need to be able to edit that text and change it. I'm going to do that through rich text editing. Now, this requires a little bit of a recap of NSAttributedString. So a lot of you raised your hands on that, so I'm not going to take a lot of time on that. Basically, attributed string consists of a string and a dictionary of attributes. Okay? And these are some of the stock attributes you can assign. Here's some code that would set a color attribute on a particular text item. So that would give you something like that. The great news here is that you can do custom attributes. So in my case, what I want to do is I want to have the user be able to tap on a song, a title of a song in my text, and have that play for the user, and bring up a little player. I can do that with TextKit. So what I have here is just an editor. This is a simple UI text view. And even just using a built-in stock components, you can do rich text formatting using the new built-in components. But that's not really exciting. What I want to do is add some more interesting stuff. And I'm actually going to jump real quick into set lists and just show you some of the other things you could do. So in this example, I can customize my text. And what we've done is actually added a text accessory view to our keyboard so we can do text formatting down here. I can even customize colors. But what's really exciting is that I can add my own attributes. So what we've done is we have an attribute called BBI chord. And I can actually assign a chord to that text. And there it goes. So I'm going to do something similar now in our demo app. So first thing I'm going to go into my editor view. And I'm going to get back into my snippets here. So how did I, well, actually, this is already implemented, so I'm just going to show you. So here's a song name. And what I want to do is add my own custom attribute to this. So what I've done is I've added a new menu item here called Insert Audio. Okay? I do that right here. Create the UI menu item. And what this does is it just gives me a popover with a list of songs. Now, if you were doing this in production, it would probably look a lot nicer than this. A list of MP4 files. And I want to assign that to this song. So I'm going to click on that. And I've done a couple things here. I've changed my attributes of the title text to bold and italic. But I've also assigned an attribute, a custom attribute, telling me that this particular text has audio associated with it. Now, since I'm editing, I don't actually want to interact with this. I also have implemented the ability that when you click on this, you can also set it to another song file or just hit none, and it will go away. Okay, so I'm going to turn that back on. And I'm going to show you how I did that. You do that with NSLayoutManagerDelegate. So again, I have sort of half a custom TextKit stack here. I've got a custom text storage, and I'm going to show you why I'm using that later. And I'm going to assign my text storage to the layout manager of the text view, which is just a standard text view. And then I'm going to set these delegate methods. Now, this is very important. First thing I'm doing is assigning the delegate so that this particular view, the editor view, will respond to the layout manager delegate. This item is also very important. Allows non-contiguous layout. What this does is it ensures that the text is laid out in order. Now, I'll talk a little later with some slides. The rest of this is just some arrays and things I do to maintain my views. And I'm going to get into the meat of it now. So when I select one of those files from that popover, what I'm doing is I'm grabbing the selection rectangle in the text, and I'm getting the original attributes from the attributed string. Okay, making a copy of those, and then if an audio file name was actually selected, here's where I'm doing that custom attribute. So this is just a string, it's called audio file. And then I'm passing in the name, the MP4 file. I'm also updating the symbolic traits of the font so I can get a little bit more highlighting around that text. So that's all this big block of code is doing. If you have questions about this, just come and see me afterwards. Finally, I'm going to create a new font style for that and assign it. And then I'm going to set these attributes on my text storage and then resign. What that will do, the text storage will then register the changes, and then it will tell the text view to relay out the text. When that happens, the layout manager delegate methods get called. Okay, so the first thing I need to do, I'm going to comment out just this, is I need to determine where in my view do I need space. Okay, so I need some extra line spacing to fit this little graphic in. You can do that with this line spacing after Glyph method. Okay, so what I do is, keeping track of what line I'm currently on, it gives you the end of the line, the glyph index. You have to convert that to a character. look up that character in the text, and then you need to search that line, and that's what this block is doing. And inside of that, I'm looking for that autofile attribute. If I find it, then I'm setting a Boolean, and then I'm returning some extra height here. That's just a constant 50. Otherwise, I'm just going to return 0. And that's how I get this to only show the extra spacing on this one line. Now, the second part of that is that I have this method, which is very important. Layout Manager did complete layout for text container. What this does is it tells you when the text is actually laid out into the text view. When that happens, I have a method here to position those callouts. And what this is doing is simply searching the text view, cleaning up some callouts, searching for the attributes again, and then here's the important part. I'm getting the bounding rectangle of the text, and that's how I'm determining where to place that callout. And I do some extra math here to position it perfectly. Okay, so kind of a lot of code for just dropping a little thing inside your text, but that's what you have to do, and it wasn't possible before. So finally, I'm going to talk about interactivity. You can do hit testing inside of your text views. So this convenient method actually tells you what text was tapped on when a user taps a view. Okay? And I'm also going to just go over dynamic layout, which I actually just showed you. So this is just a summary of the methods that I just went over. Line spacing after glyph at index, it gets called before layout is performed. You have to be very careful with this because you can get into circular calls, because the layout can, depending on what you do here, you may actually trigger layout again. So you have to be very careful with this, and I get tripped up on this all the time. And then the other important method is did complete layout for text container. This is called after layout is performed. And it works, theoretically, all the time. So in preparing this, what I actually found is that in my own custom rolled TextKit stack, this worked fine. But it doesn't in UlTextView. Sometimes it gets called multiple times. Sometimes it doesn't get called. It's really unpredictable. So you have to work around that. I think what's happening is that as the geometry is changing, it's actually calling that method multiple times as it's trying to lay that text view out. So beware of UlTextView. This is very important. Non-contiguous layout. This is good in most cases because it's high performance. It kind of acts like a text view. You know, as the text scrolls, it brings in more text and doesn't keep everything in memory, but it's not really good when you're trying to place UI elements based on the positioning of that text. And sometimes these delegate methods can get called multiple times. So now I'm going to kind of demonstrate interactivity, and that'll wrap it up, I think. So I'm going to go back to my column text view, and I'm going to add some additional layout elements here. Most of this is just for keeping track of what line spacing I'm on, what line I'm on, arrays for those call-out views, and then I need to capture what my currently selected item is. And then I have some gestures as well for when you tap on that. So now I'm going to add the handler for the gesture recognizer. So what this does is it uses that method which is somewhere here. Right there, Layout Manager character index for point. So when the user taps on something, it'll try to get the character. And then it looks, again, it finds the range of that that the character is in, looks for the layout attribute, and if it's there, it's going to tell the Layout Manager to relay out the text. How are we going to handle that? Same way that we did in the editor. So I'm not going to show that again because I pretty much went through it. Very similar here. I've got LayoutManagerDelegate methods that determine if those callouts are there. So I'm just going to run it again, and you'll kind of see what all this is about. Hopefully it'll work. So now, when the user, you'll see the text is bolded here. When the user clicks on that text, it's not going to work. Because I'm probably forgetting something. So I'm just going to start over. Hopefully this one will work. I made a copy of this project just in case this happened. That's why I don't like working with snippets. So I need to kind of put that highlighting back in. All right. Pray to the demo gods. Music also plays when the user taps on the text. All right, and now, of course, you can interact with that. Okay. Now, there is one more thing. What do I have, 3 more minutes? 2 more minutes? Let's say I'm a lazy editor, and I don't want to have to use this menu item. So I'm just going to get rid of all this. So I'm designing a little shortcut here. User can type holding my breath in brackets, comma, the name of the MP4. And now when I close that out, magic, magic. Anybody want to know how I did that? Okay, real quick. You do that by subclassing TextStorage. I'm not going to go back to my slides because I know I'm running out of time. When you subclass TextStorage, NSTextStorage is a class cluster. This basically means there are certain methods that you have to re-implement yourself. So that's all I'm doing here for these properties and methods. Okay? What you have to do is you have to create your own backing store. So that's just basically an attributed string. And then you have to implement the string method, the init method, and these methods here, which really are just passing things down to the attributed string. But the important thing here is this process editing method. What this does is it allows you to do processing post-editing, but before it's committed to the storage. Okay, so what I'm doing here is I'm doing a regular expression. I'm searching for that name, comma, name.mp4 in brackets. That's what this regular expression is doing. Searching the paragraph range that's in for that pattern. Okay, I have to grab the attributes because I'm going to do exactly what I did before, whereas I'm bolding the text and I'm going to drop in those callout views. Okay? And then the rest is pretty much the same. I'm just parsing that pattern match out into components. I'm grabbing the audio file name from what I typed, setting the font descriptors like I did before. And now I'm creating a new attributed string, including that attribute, and doing replace characters in range. And then very important, you call super, because super commits those changes to storage and then tells the layout manager to relay out the text. And that's what causes everything to reappear and the little popover to come down, and everything just works magically. Except that it doesn't. This was actually a lot of trouble. It really is. It is very difficult to work with, in my opinion. It really took me a long time to get this working right. But I do appreciate what TextKit can do for you. So on that note, I'm just going to zoom forward. Oh, wait, Joe told me a secret of how to do this. And say thanks. And I hope I didn't bore you to tears. And here are some cool resources, too, some additional things I didn't, the WWDC videos. I really think you should check out this video by Max Seelman. It's from UIConf. He covers more of the basics than I did. Also, there's this really cool article on how to do text effects, which I didn't really get into. I know we're out of time, but we're going to lunch. If anybody wants to ask questions, let me know.